All right, ladies and gentlemen, this is going to be kind of your one-stop guide for everything that we covered. In case you don't remember some stuff before spring break, need to refresh some stuff, or even the stuff we talked about yesterday, you just want to see a couple extra problems. This is going to go through everything that's on the test, and then in class here on Thursday, you'll be able to practice some of this and check some keys and make sure that you're doing it right so that you're prepared for Friday's test. So, as you go through here, the first thing that you'll see is addition and subtraction. So these have values in between here, right? I have a plus sign in here. I have a minus sign in here. So these are very different than what we talked about on Monday, which was multiplication. These have addition or subtraction between. We're going to need to add or subtract them. The addition ones are pretty straightforward. We actually don't really even need these parentheses. These parentheses aren't doing anything at all. You don't need to cross them out, but you can think of this visually without them having any parentheses at all. I'll take those off quick. And what we're going to do is we're going to just combine like terms. All adding is combining like terms. Drop your parentheses, combine like terms. So I like to go in order of the highest exponents down to the lowest because then I'm already in order and I don't have to worry about putting it in standard form afterward. Um, we do want standard forms, so highest exponent, x squared, then x, then our constant terms. So if you look through here, I see x squared is here, I see x squared is here. We're going to be adding or combining those things together. 3x squared, or in this case k, 3k squared plus 5k squared is 8k squared. We're just adding the 3 and the 5, and then the variable stays the exact same, just like 3x plus 5x is 8x, 5k squared and 3k squared is 8k squared. We're not changing our variables at all or those exponents. We're just combining like. Cool. And then our next value is our x term or our k terms here. So 4k and negative 7k. 4 plus negative 7 is negative 3. Okay. So be careful with those signs. Once again, that's what's going to get you guys hung up. Make sure you're careful about adding and subtracting positives versus negatives and how they all interact with each other. That's going to be kind of a sticking point here. So make sure you have that going on. And then finally, our last values are constant terms and things without any variables at all. That's negative 8 and positive 9. Negative 8 plus 9 is positive 1. So this is our final answer here. So you're just combining like terms when we see the addition problems here. Okay. The harder type of these would be the subtraction problem. So down here, they have a subtraction sign in between here. We see subtraction, which means we need to do something first. When I see subtraction in between here, it says, hey, we have something new to talk about. We can't do anything until we use that negative sign to everything in the stuff behind it. So that negative needs to be brought into everything behind it. Make sure you're not just taking that negative 4x. You're actually going to take a negative 1 here, and we're going to distribute it to all of these. So I like to rewrite mine out. Negative 1 times 4x squared is just negative 4x squared. And all we're really doing is changing signs. Negative 1 times 5x is negative 5x. And negative 1 times negative 7 now is a positive 7. So we're changing the sign. 4x squared was positive, now it's negative. 5x was positive, now it's negative. Negative 7 was negative, now it's positive. We're just switching those signs. And then I like to just kind of drop these guys down and say, hey, 2x, whoops, whoa, 2x minus 3x squared plus 5. So I like to just rewrite this so it's all together now. And we have this here. Cool. So now all I'm doing is exactly what we did up here, right? All we're going to do is combine like terms. I once again like to put it in the order that we need to write it anyway, since we need our highest exponents first. We're going to do negative 3x squared, negative 4x squared. Negative 3 plus negative 4, if we smush those two things together, since they have the same signs, they will team up and get even bigger. So we have a negative 9x squared. Okay, great. Then we need to look for our x's. We have a 2x and we have a negative 5x. 2 plus negative 5 or 2 minus 5 is negative 3x. Again, be careful with your signs. And finally, we're going to combine any constant terms here. We have a positive 5 and a positive 7 or a positive 12. So when you are subtracting, the biggest difference is making sure that you distribute that negative in, and then we're just combining like terms afterward. Cool. Okay. We also are going to need to distribute and then combine like terms. So our plan here, if you ever see anything in front of parentheses, we should be distributing it in, and then we're going to combine like terms just like we did at the end of that last problem. So if I distribute this guy and I say, hey, 2x in here, the biggest difference about distributing with variables is knowing how the variables interact. So 2x times 3x. Well, we're still going to do the 2 times 3. 2 times 3 is just 6. So the coefficients, the numbers in front, behave the exact same as they normally do. What we really need to talk about is what's x times x? Well, that's exactly what x squared is for. X times x is x squared. So when you're multiplying two variables that are the same together, we up their exponents. We're adding these exponents technically. 1x times x to the first times x to the first is x to the second. But anytime you multiply an x times an x, you have x squared. So that'll happen almost every time that we distribute here with variables anyway. We're going to keep going. 2x times 7. Well, 2x times 7 is just, well, be careful with your negative, but 2x times negative 7 is negative 14. And the x was there. We didn't multiply by more x's, so it's still just x. So when we multiply that in there, we get 6x squared minus 14. Then we're going to do the same thing over here. We're going to take negative 4x. It's important to note that we're taking the whole thing here. A lot of people tend to drop that negative with that 4. It is a negative 4, not a positive 4. So we're going to be taking that whole thing back there. Negative 4 times negative 4x times 5 is negative 20. And that x is still around for the ride, right? So negative 20x. And then negative 4x times a positive 4x. Well, negative 4 times 4 is negative 16. And x times x is x squared. Beautiful. So we're just distributing those, and anytime we see x times x, we get x squared. Good. Then we need to combine in like terms. I have a 6x squared, and I have a negative 16x squared. So together, those are going to be a negative 10x squared. Right? One's positive, one's negative, so they're fighting each other. And we kind of cancel out of that, and the bigger one wins. So we get a negative 10x squared there. And these guys, negative 14x minus 20x is actually a negative 34x. Those kind of team up and get bigger because they're on the same team. They're both negative, so they're on the same team. Cool. So that is our distributing. That one had pretty similar things on both the distribution parts, so they combined like terms pretty easily. You also might see one like something like this. So if I distributed this first part here, if I'm distributing this 3, this is actually stuff we did at the beginning of the year. So 3 times x is just 3x, and 3 times negative 4 is negative 12. That's not something new, actually. That's what we were able to do that kind of the first week of class, or at least second. So that part's pretty straightforward. But then we take this guy, and this is kind of the newer stuff. Negative 5x times 2x is negative 10x squared. I had x times x, so I get an x squared there. That's our new piece. That's the important part. And then negative 5x times negative 7 is a positive 35x. Cool. So then we need to go combine like terms. Once again, we want to be writing this in standard form where our highest exponents come first. What's the highest exponent here? Well, negative 10x squared is our highest exponent. That x squared is the highest. So we look for any like terms that it has. Is there anything we can combine negative 10x squared with? Well, no, nothing else has like terms, and that's okay. We'll just draw it right with negative 10x squared. Cool. Okay, so then next, well, what else is there? We need to find x's because those are the next variables. So that's the next highest. Oh, and it does look like we have some like terms here. What is 3x plus 35x? I think that is 38x. We're combining those two, writing them next. And then finally, we look for our constant terms. It looks like it's only a negative 12 here, so we're going to slap a negative 12 in the back and call it. So it doesn't every time everything have like terms to combine with. If they don't have any like terms, you can just put them in the front and the back or by themselves. Just make sure you don't forget about them just because they don't have like terms. So they should still show up in your answer. But that's a pretty common option too. Cool. So that's everything we did before break. And then yesterday or on Monday, Tuesday, I guess, geez. On Tuesday, we did some foiling. We did this double distribution, we called it, and we color coded it a little bit. We called it foiling because of this first outside, inside, last. But really, the plan is to take everything in my first set of parentheses, 2x, and this 4, and multiply by everything in the back set of parentheses. I'm going to do this in this color-coded order. We're going to say the F in FOIL stands for first. Our first is 2x times 3x is 2 times 3 is 6, and x times x, just like before, is x squared. Almost all of these, you'll get an x squared term to start because you're going to have your x times x. And it says the O in FOIL says the outside thing. So the 2 on the outside edges, well, that's 2x and negative 5. 2x times negative 5 is negative 10x. Okay, so that just took my 2x and I multiplied it by both of the pieces in the back. I'm going to do the same thing with the 4. If I follow with I, it says inside. My inside ones are 4 times 3x. 4 times 3x is a positive 12x. Cool. And then our last ones are 4 times negative 5. 4 times negative 5 is negative 20. And the good news is if we do this in the same pattern every time, the reason FOIL is so nice is because we get the same pattern every time. And these two in the middle should be like terms. Are they? Well, yeah, negative 10x and positive 12x are like terms. Negative 10 plus 12 is 2x. And everything else just drops down. So that was a positive 2x, so we're going to say 6x squared plus 2x minus 2. And this is our final answer. So you're multiplying each piece from the front of the parentheses times each piece in the back of the parentheses. It's kind of like distributing twice and then combining like terms. I kind of suggest following the FOIL pattern so that your middle ones always end up combining. Since we just did it on Monday, why don't we do one more? I'll give you one more example in case that was some new stuff. So we'll do the same thing. We're going to do the first ones. If you look at this problem, 2x times x. Well, 2x times x. We're still going to have a 2 in front, but x times x is x squared. That's fine. Cool. Then we go to our O. We talk about our outside ones. 2x and 5 is 2x times 5 is positive 10x. Very similar to the one above. Cool. We're going to do the inside ones. Negative 8 times x. Well, that's just negative 8x. That's fine. We're going to have the same middle thing. That's interesting. And then our last ones. Negative 8 times 5. Negative 8 times 5 is negative 40. Cool. So what happens? Well, these middle terms should be like terms. They are 10x and negative 8x. Well, that ends up being 2x. Well, just like above. Weird. That's fine though. Bring these down. 2x squared. This was positive, so plus 2x and then minus 40. This is our final answer right here. Okay, so you're distributing each of the front sections into the back sections and go from there. So I hope this helped. Feel free to go back, slow down and pause anything that you need to and jot a couple of these down. When you're working today, you should be checking your work with those keys so that you know that you're ready to test on Friday. This is everything that you needed to know. So hopefully this is a nice little tutorial if you do need some of this refreshed, and it'll be a nice go-to. So make sure you're good for the sub, do your thing. I will see you in a couple days.